Good morning, everyone. Welcome to the third day of FDP session. Today we have our speaker, Dr. Vani, for the topic Artificial Intelligence Overview. Dr. Vani, working as Assistant Professor, Senior Grade in VIT Chennai, School of Computer Science and Engineering. Professor has experience of 17 years in teaching. Dr. Vani has obtained, his, obtained her PhD in Computer Science and Engineering in the year 2016 from College of Engineering, Gindi, Anna University, Chennai. Dr. Vani is an expert in artificial intelligence, natural language processing, machine learning, text mining, and software engineering. To her achievements, Ma'am has acted as a resource person for AICT sponsored STTP organized by VSB Engineering College, and Ma'am has been resource person for 5 days FTP on computational intelligence organized by St. Joseph Institute of Technology, acted as session chair for paper presentation in 4th International Conference on Communication, Computing and Information Technology organized by MOP Vaishnava College for Women. About research, Dr. Vani has received fund of rupees 9 lakhs from DST for organizing short-term training courses for the benefit of faculty, research scholars, postgraduate and undergraduate students, and has executed a training course on data science and big data analytics from 10th June 2019 to 23rd June 2019. Also completed a project titled Smart Drainage System under TNSEST project scheme. One more project titled Transliteration and Conversion of Brahmi script from Antique Inscriptions under AICT Project Center for Technical Education scheme. Also completed a consultancy work for Sita Technologies. Dr. Vani has been a reviewer in IEEE Technological Innovations in ICT for Agricultural and Rural Development, InterScience Publishers, Wele Publishers. To her credit, Ma'am has published 3 international conference papers, 5 papers in national, 1 national journal, 3 papers in international journals, 6 Scopus Index journals, and in Web of Science, Ma'am has published 2 papers. Furthermore, Ma'am has 3 patents to her credit. Now, I request Dr. Vani to handle the session.
Dr. Vani ma'am is joining. She has some network issues. She's going to join in another 1 or 2 minutes.
Ma'am, sorry for the delay.
No problem, ma'am. You can disable your video so that will not encounter any network issues.
Yeah. Thank you, ma'am.
Okay. You can start the session, ma'am.
A very good morning and a warm welcome. I hope you are all safe and fine. And this, first of all, I thank Triple IT for giving me this opportunity to meet you all, at least through online, on overview of AI. Before I present my PPT, can anyone tell me what can be AI? Rather giving artificial intelligence, what can be AI in your real scenarios? I mean, real-time day-to-day life. What are the things which you are facing with AI techniques? Any answers?
Google personalizing ads for us.
Google personalizing apps, good. I don't want technical things. I'm telling about a real time. That's real date from starting. Get up in the morning, doing some work, etc.
Using GPS.
GPS, good. Which is the
Traffic is
major
in real
use.
time.
Yes. Any other things? So these are the real things what Krishnavani ma'am has told, and what are we expecting in future? We have been doing some researches on AI, something like automation. You want everything to be automated, all works to be automated, which means you are reducing the human intervention. What are you expecting next 20 years? With me, what are we expecting, first of all? We want everything to be, when we sit, everything, when whatever I think, it should come automatically without wasting my energy. That is the most thing which we all want. Whatever I think, without wasting my energy, my system should read my mind. And in the current scenario, what are we doing is we are all moving towards automation. We are not actually an automation, complete automation. We are moving towards automation. That is, we are on the work. We are in 2010, 11 only, we have started hearing the word called as AI, artificial intelligence. But this word was coined in 50s itself, 1950. This word AI was coined in the year 1950s, but we came to know only after that. And see that our leaders, that is our forefathers, they have been already working with AI. But now only we are getting into it. So artificial intelligence is nothing but you are doing some mimicry that a human should be a machine. A general basic definition, what we can on the basics, everyone can understand is that it's a mimic of a human. It's a very mimic of your human. So now, with all this, technically speaking, what is AI? Technical definition. 3 main sentences what we can remember. Stimulation, this word is most popularly used, stimulating. Stimulation of the complete human intelligence in the machine. You are just incorporating whatever human want to do, what to think, whatever to do into your machines. And you make the machine to think like a human. On a mission, which is mimic human actions. A a basic sentence which can tell you what is AI. Technical definition, whatever we learn nowadays is nothing but, as we know, we are all computer science engineers or communication engineers, whatever it is, it's a subject of computer science. Where are we building all the operations? Like whatever humans think, it's been converted to all mathematical operations and which has been embedded into a system. So in general, subject of computer science, which has been aimed on building a machine to enhance all the operations. All the operations, which means that whatever we do, whatever humans do, whatever we people do. This AI, whichever we speak, is nothing but the overall view, the world, that is your global view is called as AI, which means that you're going to program the complete system. You're going to program the complete system. That is overall. What program I'm going to do, what algorithm I'm going to use, what concepts I'm going to use, that becomes a machine learning. So machine learning, in general, we can tell it's a subset of AI. So AI is a global view in which the subset is called as machine learning, where we have some set of mathematical expressions, set of algorithms which is to be incorporated or should be programmed to make the machines learn. So we call it as machine learning. So in general, your machine learning is a subset of AI. We would have heard all these words. Now, not now, just like 5 to 10 years before, they have started working out something called as deep learning. From the word deep learning, what do we understand? As I told you, your global view is your AI, in which it has some shelter or some subset, we call it as machine learning. In machine learning, we have another subset in depth, each and every nook and nerve of your brain to be read, which is called as deep learning. Would have heard all this, but now we have been working with the other subset of deep learning called as DBN, which is recently on the research place, which we call it as deep belief network. What is the meaning of this? Something called as deep learning. Ma'am, you are speaking about something called as deep learning. And what is something called as deep belief network? From the word deep belief network, what we understand? As you know, we are already learning in depth. You're analyzing, you're doing an analytics process, or you're analyzing set of data in depth. We call it as a deep learning in general. Belief network means the data what you retrieve is being connected. Whatever you see, data was whatever you get as output or whatever you see, which we call it as a visible units. And these visible units are being connected to some set of other nodes called as hidden units. Say, for example, I am the resource person for this 1 hour class. I have been delivering some content, but I may be connected, you know only me, but I may be connected. All these informations may be connected with some different places which are completely hidden, but I am only visible to you. So your deep belief network will analyze or will accurate the data which is visible to you, and it will inform or will get the informations how are they being connected with other set of data. So we call it as a deep belief network. Here two main keywords, which is visible unit and number 2 is hidden unit. So overall, AI is a global view. Machine learning is a subset of AI, which is having some set of mathematical concepts or some set of algorithms is to be incorporated. After incorporating these algorithms, you have to reach to the depth of your data, which is on artificial neural networks, which is completely about deep learning. The subset of deep learning is called as deep belief network. Now you can ask me a question. Where is data science? You have been attending these FDPs on data science. Ma'am, you're speaking about AI, you're telling about what is machine learning, you're telling about what is deep learning, and you've told about what is deep belief network. And where is this data science? Here. So, as you know, in 1950s, as I told you, this AI word was coined in the year 1950. As in 1950s, you may have only some set of data which is in your handful of data. But nowadays, there are a voluminous set of data which are not measurable. We want to retrieve all these informations. We have to do some operations. We have to get some results. We have to show the performance, whatever it is. So we are moving on for voluminous of data. So we are working on big data. So your deep learning concepts is being fused with big data and the concepts of AI, machine learning networks with something of nowadays, as data have been increasing, we have been working on something called as data science. From this picture, you can understand. This first picture has just told you about this is a subset of this and this algorithm subset of this particular part, etc. But the second picture is telling you with all these concepts, since your data are being growing, as you know, we are all software engineers. Your data are being growing. We have been saving in, now we are working with cloud. We have been working with small set of databases. Now we are putting all data in your cloud. Your data are being growing. So we are working with big data. And with this deep learning concepts, whatever ideas, whatever manipulations, whatever you're going to retrieve, whatever we need. So we are now working on data science. So they are not different. Data science is not different. Big data is not different, etc. They are all under the shadow of something of AI. What is the importance of AI? First of all, the main why are we moving on to AI is nothing but we want to make our lives very easier. Day by day, we are on to the competitions. Day by day, we are been releasing n number of products. Day by day, we are been giving out n number of results. So we want our lives to be more easier. If it is easier, you should not mean that all the information what I'm getting is correct or wrong. So you have to prove your efficiencies also. That is, you have to improve your efficiencies. As you know, humans, whatever information we give, they think first. They take some set of time. Their time is being wasted. Say, for example, if I'm giving some question, if I want to ask you a question, after a few seconds, there will be some answers. Humans think. Their time is wasted. But the machine, when you give the input, you get the result automatically. It reacts more quicker than the human. And main thing is that machine does not go down. Human sometimes it's mood off. Say for example, why are you so dull? If you ask your friend, she will tell that my mood off today. I'm on mood off, so I'm not going to work today. Your machine would not tell that. So we are replacing the humans with machines, which means that machine will work for 24/7, but humans is not like that. So these are the main importance of why are we moving towards AI. So these are the merits. Of course, whatever concepts have been, there are demerits also. When there is AI, which is fully incorporated, automatically there are pressures on humans, which is reduction of humans on work. So, though there are n number of merits, there is a major demerit on AI. Other things, other example, a real-time example which I can tell you. Many people would have, they have been watching our TV, have been watching TV. We would have seen the soap ads, like your hammam soap ads. The mother would tell her child that go and get the soap. But the girl, she leaves the house. She leaves the house immediately, getting the instructions from her mother. After the girl leaves the house, mother thinks, she's thinking, oh my God, I have not told her what soap should she buy. This particular girl has read the mind of the mother, and she has bought the correct soap what the mother thought. This ad has come before 10 years before, which is a real typical example of AI. So human as a mother, the girl becomes a machine here now. She has read the mind of a mother because she knows how she reacts, what she buys, she knows what to give at what time, she knows everything. This is a very real-time example of an AI, which I used most frequently used example in my class, where my students used to understand much easier. So in general, your importance of AI, you make your lives easier, first thing. Second thing, your machines does not go down. It works for 24/7. And machine takes very good decisions when compared to human. And it is very fast also. That is a major merit of the AI concept.
Excuse me, ma'am.
Yes.
I have two questions.
Yes, sir.
What is the difference between big data and data science? This is first
Sir,
question.
actually,
and second,
yeah. Tell me, sir.
Yeah, please continue.
Yes,
then
sir.
I will ask you second question.
Sir, your big data is nothing but you're mainly focusing on the amount of data what you have, what are the operations you're going to do with that, and what you're going to retrieve from that. It's mainly focusing on that alone, which is on the volume of data alone.
Okay.
But for these, ma'am, you're going to retrieve, you're telling that this volume of data, you're going to retrieve some informations. We have to use the algorithms there.
Yeah, right.
You'll ask a question, but it's focusing only on the amount of data which I'm going to take for my input and what is the process I'm going to do. That's all. This is your big data. Your big data word was coined only based on the real-time data or whatever data you're taking for your manipulation process. From there only the word was coined.
Okay.
Now, these after your data are being increasing, there are n number of algorithms which has been getting inside. Then they work with all these data and the algorithms what has been framed. We have the concepts called as data science.
Data science. Okay.
What is the science, sir, actually? What is the science actually? Can you tell me what is science? Hello? Sir? Science is a common name which is being given for n number of works. So we have data which has been processed under different categories. So now your machine learning, from this picture machine learning, there is in machine learning, you have human interventions. The picture has been given, feature extraction has been done by human. But in deep learning, you can see that human intervention is reduced. That is the major simple difference between what is machine learning and what is deep learning. Human intervention is reduced in your deep learning when compared to your machine learning. So first, your thing is that I'm giving an input, a program. I've written a program in your machine. I've given the input to be your car. My system should identify whether it is a car or it's not a car. That is my expected output. These are test cases which I've written. It should be a car or it should not be a car. So in machine learning, the input is given. With some human interventions and human ideas, we extract the features, classify the data, and predict your output. This is the basic steps which has been happening in machine learning. What is happening in deep learning? Your machine itself will extract the features by reducing your human intervention or human involvement, classify the data, and predict your output. Very simple, major, basic phases only, but only with slight changes. As you know, your softwares are being released. Say, for example, today your software releases version 1. Tomorrow it can be version 2, only with a very slight change. The same way in machine learning, you have a n number of algorithms which is having some statistical tools for classifying your data. So your machine learning is going to predict whatever input you give. It will predict whether the data what you have given is whatever test case what you have written with some human involvement. In deep learning, the feature extraction and classifications are being done automatically. In traditional machine learning, we don't have all these ANNs. ANN is nothing but an artificial neural network. In deep learning, we use a concept called as artificial neural network. I think in your childhood days, you would have heard the word called as neuron. We would have all learned in 10th and 11th, 12th standards, we would have learned the structure of a neuron. That is the basic idea of your neural networks. When one instruction is being given, it will move on from multiple points, retrieve all informations, do some extractions, whatever you need, do some retrievals, whatever you need, and then the output has been given. So this neural network, this neural word was coined in computer science only based on the 12th concepts or 11th concept, whatever we have learned in biology, which is your neuron concept. So your basic difference between what is ML and DL is nothing but ML comparatively, it will train only lesser amount of data. In DL, it will have more large data sets for training. What do you mean by training? The basic things. What do you mean by training? Training a system. Say, for example, I am a team leader here now. There are some set of people under me. I am a trainer now. When do you use a word called as trainer? We know the concepts. The people under me, they also know the concept, but I want to give them a depth information of the organization where they're working. I have to give the input. I have to tell them this is the process you're going to use, this is the place you're going to use, this is the system which you're going to use, and this is the work you're going to do. I'll tell them step by step. I'm training them to their sequential process. So this training in ML, comparatively, it has less amount of data, but in DL, it has large data sets. First major difference between what is ML and DL. Second difference, since it has less amount of data, it takes only less amount for your training process. Here, automatically time may increase. In ML, it's enough if you use CPU, central processing units. You train on CPU alone. But since you have large amount of data sets, we need, in deep learning, we need GPU. Are the major differences between what is ML and DL. This picture would tell you what are things which I have told you in previous 9 slides. AI is nothing but you're going to design a complete system. You're going to design the complete system. Machine learning, which means that for this particular system, your brain becomes the main part. How I'm going to train that? With some set of algorithms, some set of operations, etc. In this particular brain, I want to have the main part. In brain, we have n number of places. Where is the actual processing unit? What I want to do there? That becomes your AI. Nook and corner of your nerves will be taken into consideration. That is, not even a single point of data would be left. You move on to the depth of the data, whichever you have. So picture AI is nothing but the overall thing which you're going to design. For designing that, what is the main central unit? Brain becomes your central unit. How I'm going to do that? What are the operations? What are the algorithms I'm going to use? What are the data I'm going to use? Which is numerical data or your images or time series, whatever it is. Based on that, the brain should work. For that, I need the machine learning concepts. And then, in this machine learning concepts, we'd have focused only on some certain parts or certain data alone, or some set of certain situations alone. In deep learning, what I'm going to do is not only focusing on specific area, you are focusing on the remaining adjacent areas also, which becomes your deep learning. I think that would be very clear with this picture which is being shown here now. So AI was being framed in the year 1950 itself. In 2010 itself, we have heard about the word called as DL. But we are in 2020 now. We are working on DL now. We are working on deep belief network. Now, can anyone tell me what is analytics? What can be analytics? You know analysis, analyze. This analytics word has come from analyze. What do you mean by analyze? When a particular scenario or any case study which has been given to you, some situation has been, you are facing some situation. You have to react for that. What do you do first? We will all first read the situation, at least a fraction of a second. What are we doing now? What is the problem I'm facing now? That is your descriptive analysis. First one, what happened to me? Why am I like this now? As humans, first analyzation what we do, or analytics what you do, is nothing but you move on for descriptive analysis. Descriptive is nothing but just read what are you facing or what is before you. That's all. Technically speaking, which is nothing but it documents whatever we have. Say, for example, I'm working on some project. I'm facing some problem. What I'll do now? I'll just take the document which I have prepared. Where is the problem actually? It has been occurring. Where it arose first of all. So your descriptive analytics. So analytics can be divided into 3 main parts. Those are people who are doing researchers, who are researchers here, or we are all been working with all your day-to-day data. We have been working. We do research in all information what we get. So first what you do is we move on for descriptive analysis, which means what has happened. What is the problem which I'm facing now? Descriptive analysis. Next, diagnostic analysis. The word diagnostic is being used in the word near medical field only. Medical field is a very sensitive field. It's playing with your lives. So diagnostic analytics, you use a word called as diagnostic analytics, which means that why it has happened. Find the reason. What has happened first, which is overall view. Say, for example, I'll come and ask you, why are you so dull today? What is the problem? You will tell me that, okay, this was the problem which has been facing and this is the problem. So descriptive. I'll just ask, I'll share your thoughts and then leave. Diagnostic. If I'm a close friend of you, the sentence goes like this. If I'm a close friend of you, I'll try to solve your problem. I and my friend, that is you, would join together and find why it has happened. What can be my contribution? What can be her contribution? So you analyze. So we call it as diagnostic analytics, where your mathematical logical operations get involved. You zoom your camera. The other example is that you zoom your problem. Diagnostic analytics. What is predictive analysis? Nowadays we are working on only on predictive analysis or predictive analytics. Predictive is nothing but if I'm solving this particular problem, if I'm not solving this also, what would happen in the future? So when we did research, we were working only on descriptive, that's all. Sometimes we are working on diagnostic analytics. But nowadays, all researchers, including me, on working only on predictive analytics, where not only we are solving the current problem, we are focusing on, if I'm going to solve this particular problem now, will it have a greater impact in the future? What would happen in the future? So there are analytics, you play with your data. Analytics means that we are going to play with the data. We are going to play with the images. We are going to play with the time series of certain data or some set of lot of information. We're going to play. We are just playing. That's all. We researchers or we doctorates or whatever we learners are playing with data, finding new things. How are you doing this? First one becomes your descriptive analytics. First, analyze what is your problem. Was there the problem like this previously, based on previous documentations? What had happened? Descriptive analysis, descriptive analytics. Next, if you are very clear with the problem, somehow you should solve because you are the problematic person now. You have to solve. Diagnostic analysis. Zoom your problem, find where is the actual problem, where has it arisen. You have n number of documents in which some say, for example, I have 10 pages of document. In the 8th page only, the problem has been started. Other real-time example, if you are teachers, you may have 60 students in your class or 30 students. Descriptively, you have found that, okay, my class is good. But your previous teachers would have told that this class is very good, you can take this particular subject. It's not a problem. Diagnostic analytic, which means that out of these 30 or 60, there would be 2 persons who play a major role on your problems. Diagnose, solve that particular problem. Your class would be a perfect class. That is a diagnostic analysis. Why it has happened? Who is the source? What can I do for that? Predictive analytics is nothing but I have done everything, I have sorted. I sorted these 2 problems, the problems which have been faced by these 2 students. Further, in future, if I'm going to face the same set of students or some extraordinary students, what would happen? So what would happen in future becomes a predictive analysis, which is playing a major role in AI. That is the reason I'm speaking about what is analytics. So kindly work on with all this. Those are working with those are working with research or any kind of concepts, end up with predictive analytics. Now, we have heard lots of stories about what is AI, ML, DL. Now, I'll tell you what's the major, in short, I'll tell you what's the difference between AI, ML, and DL. AI is nothing but, as I told you, it's a mimic of human. A human, this symbol is used for human, generally we know as software engineers. AI is a mimic of human. ML is nothing but some set of statistical tools which is used for making a human into machine. I think I'm clear. Some set of statistical tools, I can put another way. Tools to explore your data, whatever data I have. Tools which I'm going to use to explore your data, understand, explore something, but you understand the data. You make the machines to understand your data. Some set of tools which is used to explore your data. Now DL is nothing but a depth knowledge of ML, that is subset of ML. The basic difference between what is AI, ML and DL. Can anyone tell me which plays the very major role, AI, ML or DL? Which plays the major role here now? See, whatever we do, we are speaking at, ma'am, I am using this, I'm solving this particular problem using some ML algorithms. Though I am working in image processing, I am using some set of algorithms. Though I am working on some kind of networks or whatever it is, we use some set of algorithms. You train your machine. So your machine learning concepts plays a major role for origination of DL. So here, this ML, there are 3 types of algorithms. I think the forthcoming resource persons would tell you with some set of data, they'll practically explain you what is supervised. I'll just now tell you what is supervised learning, what is unsupervised learning, and something called as reinforcement learning. So first algorithm is supervised. Machine learning algorithm, first one to be your supervised algorithm. Second algorithm to be your unsupervised algorithm. Third one, it's nothing but reinforcement algorithm. So machine learning, or you're going to train your machine using any of these algorithms based on the input which you're going to take. So there are 3 algorithms which has been categorized. One is supervised algorithm, number 2 is unsupervised algorithm, and number 3 is reinforcement algorithm. What is supervised? You know the data would be labeled. This is a common word which everyone uses. Data are labeled. Data are labeled. That is called a supervised learning. In easier form, I can tell you, based on previous experience. Say for example, you are going for a class, there is one student or some set of students where they score more than their average marks. We call them good students. So wherever you go, say for example, you are handling for the particular batch, second semester, third semester, the person, say for example, I am handling for fourth semester for same class. You would tell me, you would train me and tell me that in this particular class, this particular set of students are very good. You have labeled them. Based on your experience, you have labeled them that these 10 students of this particular class are very good students, both in knowledge and on their activities. This is called as supervised learning. I think I have given a very simple example. You have labeled them based on, you have trained their students based on your experience. You have labeled them that in this particular class, these particular students are very good students, both in academic and both in non-academic. So I can put the sentence in this particular way, technically speaking, or in science, like computer science language, we can tell you, based on past experience, data are labeled for prediction. So supervised learning, based on past data, we label. The other keyword to be kept in mind is labeling. On this labeling, you can predict your output. You can predict your output. Very simple. Supervised learning is nothing but only 3 keywords, what everyone can take into mind. Based on previous experience, previous data, you give them a tag, a name, label them. Then predict what can be your future output. This is called a supervised learning. Any other real-time example? When I go to a doctor, when I tell my height and weight without seeing me, say for example, I'm speaking through phone. I'm telling me that this is my weight and this is my height. Automatically, the doctor would tell me whether I am obese or not. He has not seen me. I am speaking only through phone. I have given only 2 inputs, which is height and weight. So doctor becomes a machine here now. Based on his previous experience, he knows that when a particular person of this particular height, of this particular weight, the output would be whether he or she is obese or not. A very simple example of what is supervised learning. I think I'm clear with what is supervised learning. Any doubts? Now, what can be unsupervised learning? The reverse of supervised learning. You don't have the past data. You don't know what is the problem. See, you know what is the problem, but you do not know what is the previous experience. Though nobody would have experienced that. You yourself should break your head. You have to label. You have to find the solution. So no labeled data would be available in your unsupervised learning, which makes your prediction tough. Don't know the output. So you have to start the work without knowing your output. But in supervised learning, you have to start your work, you know where you're going to reach. You can predict where you're going to reach. But in unsupervised learning, since you don't have the past data or previous experience, or you don't have labeled data, you don't have knowledge about what would be my output, which is unsupervised learning. Question mark comes here now. Okay, ma'am. Supervised learning is much easier. Unsupervised learning is little tough. How we can solve this particular problem? There is a problem in unsupervised learning. That is, we don't know how to predict the output. How we can solve this? This can be solved on clustering techniques. This particular unsupervised learning has some set of techniques which is to be used, which we call it as clustering techniques, which is K-means algorithm. Say for example, I am in a point. Nearby points will start communicating with me. You don't know who are your near points. You don't know anything. Based on that, you are going to get the output. So it K-means clustering techniques is being used in your unsupervised learning. In a single sentence, based on the similarity, based on the similarities of data, you can move on to your expectation of your results, which is unsupervised learning. What is reinforcement? Reinforcement algorithm is nothing but the combination of supervised and unsupervised. Your data, whatever you take for your processing, some part would be supervised and some part of data could be unsupervised. So reinforcement learning is also called as semi-supervised learning. Semi-supervised learning. So machine learning, you're going to train your system, machine, with any of these category of algorithms. One is supervised learning. You can learn your system. You can make your system to learn based on supervised process. You can make your system to learn based on unsupervised process. You can make your system to learn based on your reinforcement process. So supervised learning, you know what is the problem. The same problem would have occurred based on previous experience. You can predict what can be output of your problem. But in unsupervised, we don't have the past data, we don't have the labeled data, we don't know what will be your output. How it can be solved? It can be solved based on some set of clustering techniques, or it is working on similarity process. Reinforcement, very simple. Combination of supervised and unsupervised, which is some part of data will be labeled and some part would not be labeled. Based on this, you can sometimes predict the partial output, or sometimes you would not be predicting your results. This is, it will be differing based on the application or the problem which you are going to take. So this is the major thing which is to be taken into care in machine learning. Now, DL. So I've told you what is AI. AI is nothing but the global view. That is the reason I've told you only one sentence, mimic of a human. Machine learning is subset. That is, you're making human brain to work now. For that, human brain is the main source. For that, we need some set of algorithms. That is the thing which I told you in machine learning now. Now, deep learning. Deep learning is nothing but, as I told you, subset of machine learning. You are going to have mimic of human brain. This sentence in AI is nothing but mimic of a human, I told you. In deep learning, the word is nothing but mimic of a human brain. Only a part of this particular body, let's say your main brain. This has been done using neural networks. As I told you, your brain has, as you know, you get instructions. I think you can remember the neuron diagram. You get the instructions from one place. It's been getting diverted out. It's been flashing out in all places of your brain. You take decisions. Neural networks. Then create the neurons. What are the techniques which is being used? Techniques which is being used in DL are, number one, ANN. ANN is nothing but artificial neural network. ANN is nothing. First I'll tell you what are three techniques. First one to be your ANN. Second thing to be your CNN, convolutional neural network. And the last one is recurrent neural process. Your techniques, there are three techniques: ANN, CNN, and RNN, where R indicates your recurrent neural networks. What is the difference between ANN, CNN, and RNN? Very simple. ANN is, the data would be in form of numbers. If I'm going to take the input of data, if it is numbers in deep learning, just blindly can take artificial neural networks. Very simple. Your data would be numbers. In ANN, data would be numbers. In CNN, your data would be images. If it is images, the technique which I'm going to use in your DL is nothing but convolutional neural network. Data is, numbers are over, images are over. What is recurrent neural networks? When I have series of data. When I have the input to be series of data, time series. So DL, subset of ML, which is a mimic of human brain, which is using the concept of neural networks. The techniques which has been used in deep learning are, there are 3 techniques. One is ANN, most popularly used ANN. Number 2 is CNN. Number 3 is RNN. ANN is nothing but when I'm going to take the input of data to be numbers, I can use your ANN concept. When my input is in images, convolutional neural networks. If it is time series of data, you can move on for recurrent neural networks. This is the major difference between what is AI, ML, and DL. Previous 11 slides, whatever stories I have told you, all is being put up in a single content of easier understanding of what is AI, what is ML, and what is DL. Now, here ML becomes the major part. That is your mathematical process, your manipulation process, your actual working process. Everything is only with your machine learning. So now the basic difference, artificial intelligence was being, as I told you, it was being coined in the year 1956 by a great person called John McCarthy. Machine learning in the year after 3 years. They have designed or coined the world called as machine learning, which was being given by Arthur Samuel. Deep learning has started in the year 2000 itself, but now we are working, which is Heisenberg. I have told difference that it is a machine mimic behavior. You make the machine to learn, and it is the function of your human behavior. Here, machine learning, your training is low because your data are less. Testing is high. Vice versa in deep learning, training is high because you have large amount of data. Testing is low. So you make the machine to think here in AI. In machine learning, you use some set of statistical tools that I told you to explore. That is, you understand to understand your data. Explore means that you understand the data. And your deep learning is the mimic of your human brain, which I told you. Basic difference of what's AI, machine learning, and DL. Now, why deep learning? See, AI is over. We are working with ML. Now we are moving on for DL. Why it is DL? In older algorithms, as the data are been increasing, our concept, our software engineer concepts or computer engineer or automation processes that though the data are being increasing, our performance should also be increasing, it should not reduce. That is our main aim. As researchers or scientists or some person, we have to think that as data are been increasing, though the data are being increasing, your performance should not reduce. So here, when amounts of data has been increasing, the previous algorithms get saturated in one place. But deep learning, since you're reading out each and every nerve of your brain, you're reading in depth, we move on to something of deep learning algorithm. So your performance always been increasing, it has not been at a saturated point. So your machine learning, there are 2 types of learning. One is shallow learning and deep learning. Shallow learning, both the learnings have supervised and unsupervised. In shallow learning, we have support vector machines. Just I'm summarizing what are this. And forthcoming thing and what I'll tell you what is currently where are in AI, in which place are we? In 2020, where will we? Or 2040 and 2060, what are we expecting? So in deep learning, you are going to read the data into the core, to the leaf of your information. We are working out with some DBN, which I told you in previous slides. This you have learned what is clustering, what is association. I've told you what is convolutional, etc. So in general, your machine learning is being based on 3 main things. One is supervised data and unsupervised data and reinforcement data. Here, I think you would accept this particular sentence. we are the most successful species on earth. Why? We are the most successful species. We are one of the species. Why are we most successful? Only thing is that we are able to speak. Communication. You can ask me a question, ma'am. Even animals speak with their own language. But everyone, we don't understand this. But we are the main thing. We are the main species. But though the communication is the main advantage, it's very much complex. There are different languages, more than 6,500 languages. But in this 21st century, we are doing a number of researches. You know that data are structured and unstructured. You know what is structured and what is unstructured. Can anyone guess, in current scenario, current situation, how much % of data is being structured? Any guess? We are playing with your data. We are storing information in the n number of formats. Any guess what is the percentage of data which is being structured in this particular century? It's only 25% of data are structured. This is being given by n number of researchers. Currently, there is in August 2020, I had a paper where they have done the research and give the information that only 25% of data are being structured. But we are just working out the n number of data. We are storing with n number of informations with n number of formats. Here plays a major role. AI, artificial intelligence. There is some communication, human language. You need some set of computer science algorithms with all this Venn diagram where the commonality is nothing, but now we are working with something called as NLP, natural language processing. We are automating. For that we need artificial intelligence. How are we automating? What is NLP, natural language processing, which is human language, human communication, human language. For that I need some set of machines with some configurations or with some set of algorithms or set of manipulations, whatever it is, say computer science. So with this, we are now working with natural language processing, which is a part of AI. So now I told you what is AI, what is machine learning, I told you what is DL, touched upon what is DL, I touched upon what is DABN. Now I'm touching upon something called as NLP, which is nothing but your natural language processing. So your natural language processing is under the shadow of AI, which is making or using the ML and the DL concepts. Your NLP, so I told you what is DL techniques is being used. Machine learning techniques I have to now have to touch upon with something called as NLP, where NLP has two main components. One is natural language understanding. You have to make your machine understand what is your natural language and then generate what is the actual output. So you have to know about what is NLU, and second component is NLG, natural language understanding, natural language generation. Can anyone guess which would be the most tedious work? Which would be tedious work out of these two components in NLP? Any guess? It's nothing but natural language understanding. First, we have to understand. Say, for example, I'm speaking with you now. If you know English, it's much better. If I speak in English, you'll be able to understand. If you don't know the language I'm speaking, There is no use. I have to waste my energy, my resource, my input. I'm not getting any output because you don't know the language. First, I have to make you understand. So understanding component is NLP. And in NLP, you have two components of NLU and NLG, where NLU becomes a tedious work or a complex work. When that becomes easier, generation becomes automatically easier. When you understand only, you can generate results. So NLU becomes your complex process when compared to your generation. So in NLP, NLU, you have to take the text, whatever language, if it is English, Hindi, or whatever language you take, Tamil, whatever it is, whatever language you take the text. Find the meaning. NLU, from the text, you find your meaning. Whatever you speak, you have to understand. I have to find the meaning. And then only I will be able to respond to you. Text to meaning, which is NLU. This becomes a very important complex process or important work in an NLP. When this becomes easier, from the meaning I can generate a text in whichever language you want, which is natural language generation. In short, NLP is nothing but the addition of or summation of understanding and generation. Understanding from text to meaning, generation from meaning to text. So very simple, very clear diagram, which is nothing but you speak. That is being converted or a text are being taken from the speech which is being given. Find the meaning, which is NLU, where you have speech recognition. So in NLU, you work on speech recognition. From the meaning, what I have the centralized point, the meaning which I have got, after the understanding process, I have to move on for generation of results. For that, meaning would be the input. You have to identify the text and then give your response through your speech, which is speech synthesis. Natural language generation. So in natural understanding, speech recognition, you have to recognize what he is speaking. And here you have to move on for speech synthesis in your natural language generation. The language technology has been happening. Automation, nowadays automation has been done. Your system, say for example, you're working with system, I'm using my, in forthcoming years that would happen surely. When I'm using my system, say for example, I am a Tamil person or whatever language it is. If I speak in Tamil, your system understands and give me the results in whatever language we want. You need not have the moderators in between any two persons. It's also been working now, but it's not fully automated. So in NLP, there are levels of analysis. One you have to do for morphology analysis. You know what is morphology? Syntactic analysis based on the syntax. Semantics, which means that a meaning of that particular text which you have taken. Discourse, what are the remaining things to be done? So in NLU, I have this diagram is not been taken from some place. This thing which is being made very easily understandable for the persons, where you take the words, that is your text. You do some morphology analysis, that is your pause tagging. You know what is pause tagging? Parts of speech. In English, in your school days, you have learned determinant, verb, noun, etc. So your text would be, your speech would be in sentences. Each and every word should be tagged now. A sentence may have n number of words. Each and every word is being tagged, and that is called as pause tagging, parts of speech. Then find the syntactic analysis, which means syntactic structure, which means that after the verb, there should be a noun. Before the verb, there should be a noun with a determinant. Some kind of formulas, syntactic structures. So whatever syntactic structures we have taken, find the meaning, whether the meaning is being coming correctly or not. Semantic, which means that meaning representation of the particular word, actual meaning. I can give an example. She went to the bank. She went to the bank and enjoyed her time. What does this bank indicate in this particular sentence? There are two things. Bank can be, a meaning can be two forms. One is bank can be a money bank. Other bank can be a river bank. So most frequently used is your money bank. So we would think that it's a money bank, but the actual sentence would be on river bank. I have given sentence forthcoming that she enjoyed her time. We don't enjoy our time in the bank. We enjoy our time only on the river bank. So for appropriate words, you have to find the meaning. So semantic analysis. Discourse processing is nothing but checking out with the syntactic and semantic, find the actual meaning. What is the actual meaning? Say if it is, what is it? It's a river bank or it is money bank. I have focused only on river bank. So the answer should be she was on the river bank only. So full meaning representation is nothing but your discourse analysis. We are doing automation. This AI systems have been, there are AI systems which has been working on all this. So NLU, from the words you have got the actual meaning. I told you from the text to meaning of the text becomes your natural language understanding. So now in generation, what I do now, from meaning to text I have to do. I have got the meaning now. I have got the meaning. Next step, natural language generation. From the meaning, you have to utterance planning, which means that meaning that particular word should be put up in the sentence. Then find whether it's correctly suited or not. Then find the choice. Generate the sentence. Then give the words. That becomes, your understanding becomes a very tedious process. That has been much easier. Exact meaning is being retrieved. This is not this generation does not have a lot period of time to work. Only shorter period is enough. Example. I have given a sentence that Google CEO Sundar Pichai introduced a new pixel at New York Central Mall. Example, I'll have to work with NLU now. You have to understand, natural language understanding. I have given a sentence now. What I have to do now? This Google would be, say for example, Google can be a place, but we always refer to an organization. So pause tagging, your pause tagging is being done. You know that you would have already heard a word called as many things. You would have word called as chunking. NLP has a chunking process. Chunking is nothing but you have some set of data, but if I had some other extra data, I would get the actual meaning. So you add piece of information to the original information to give the actual output. You do some chunking process. So now this NER, your named entity recognition, NLP plays a vital role in NER, which is nothing but named entity recognition, where entity becomes your organization, person, it can be a thing or it can be a device. So now, what are the NER concepts in this particular example? Google becomes your organization. So Google CEO, I can have this Google CEO. CEO cannot be tagged with any other person because I have the word called as Sundar Pichai. So I'll give it as a person. Sundar Pichai becomes a person here now. So NER, named entity recognition, which means that you have to tag these particular words with an organization, or it can be a person, or it can be a thing, or it can be a device. So Google becomes an organization. Sundar Pichai becomes your person. Introduce becomes your verb actually. Yes, done some work. New pixel, some set of things which is being given. New York becomes your organization, and Central Mall also becomes an organization. New York is not it's not an organization, it is a location, sorry. So NER also has a location process. So in natural language processing, in NLU, you have to have a concept called as named entity recognition, where each and every sentence, whatever we give into system should understand my system should understand my sentence, and then automate. For that, I have to move on for named entity recognition. This named entity recognition can be of location, organization, person, thing, or a device. I have given the example here now. Your system will divide these into parts: organization, place, verb, person, location, organization, etc. This is called as named entity recognition, which is a part of NLP. DBN I have told you, which is visible. I have told you in previous slides, which is visible units and your hidden units, hidden nodes. It's not a condition that whatever visible units you have, that many hidden should be have. We have n number of hidden things because they will be interconnected. AI algorithms in forthcoming, I think forthcoming session, they would handle any of these things. There are n number of algorithms like linear-based algorithm, decision tree algorithm, random forest, SVM. The most thing is SVM is most popularly used. K nearest neighbors, linear regression, lasso regression, logistic regression. There are n number of algorithms. These are the most frequently used algorithms. Now, with all these last 1 hour or more than 1 hour, I have just given the overview of AI, how a human can understand what is machine learning. I've told you what is DL, and then we moved on for the concept. With all this, there is a concept called as NLP, natural language processing. I've told you. With that, I've told you what is NLU and what is NLG. I touched upon the current part of something called as named entity recognition. And now, what can be future of AI? Today we are here, which I call it as, which not I, which everyone, artificial narrow intelligence. We have heard only AI in today as on date, but actually it is called as artificial narrow intelligence, which means that you are just trying to mimic like a human. You're trying to mimic like a human, less than human intelligence. Surely in current scenario, we are less than, the system is less than human intelligence only. Because we have to give the input to the machine. In 2040, what are we expecting is that it will be equivalent, your AI would be equivalent to human intelligence, which is called as AGI, which is called as artificial general intelligence. Equal, general means equal. So artificial general intelligence, that system would be equivalent to your human intelligence. But now, to some extent, the system is lesser than the human intelligence. We are on that particular place only now in this 2020. In 2040, they are expecting your systems to be equal to human intelligence. Okay, ma'am, we are in 2040, we are going to reach. What will happen in 2060, which I call it as ASI, artificial super intelligence, which means that we cannot touch the machine with the human intelligence itself. It will be far greater than our thinking. So I've just, as of, I know only a little drop in the complete ocean. I've touched upon what is AI alone, not with the depth part. I've just given an overview of current scenario today. But 2040, our future generations would be coming to know about what is AGI, which is artificial general intelligence. That is, your car would drive without a human. See, it's already in foreign. We are working in foreign countries. They are working in foreign countries. It is not actually into implementation. System, that is, you would have seen this robo film, Rajnikant's film. It's the best example for AI that everyone knows. In 2060, researchers have given a statement that your system would be far greater than the human intelligence. That is artificial super intelligence. So now your subjects will turn into, now we are learning AI. Forthcoming subjects will be AGI. Then forthcoming subjects will be renamed as artificial super intelligence. So this is the future evolution of AI. So today we are weak. We are just, we are on weaker section. In next 20-30 years, we will be on a strong section. That is, we will be able to compete with the machine. We will be strong enough to tell that I will be able to compete with the machine. But in next 45 years, we will be autonomous. Not we, your system would be autonomous. We will be in separate place, system would be in some other place. This is the actual impact of the forthcoming AI. Now see what will be our work. The sentence which I told you, there is a major demerit, is nothing but human work will be reduced. So in 2060s, think what will be our job. One system would be able to do 100% work. That is the thing. So we are working on artificial intelligence, which is making your life easier, your work easier, which is working for 24/7, which is giving accurate results, which is much faster than human brain. But with all these advantages, there is a major demerit. So we are waiting for AGI. If there is a case, we'll move on for what is ASI, sorry. And I want to share a particular link in a YouTube where the CEO of Microsoft, CEO of Mason, our great leader Sundar Pichai, have told few sentences. What is the future AI? I'll just take upon this particular video. Just for 3 minutes, you can see that particular video where they have told you what are we expecting. Are you able to see the video?
No, ma'am.
1 second, sir. Now are you able to see, sir? Now are you able to see your video?
No, still it is not showing, ma'am.
And improving this artificial intelligence software. So it's
Yes,
very
it's coming
exciting.
now.
Software
Yeah.
is
No,
going
no,
to
we
solve
can
that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we've talked about on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
We could able to see the video.
Wouldn't it be wonderful?
Ma'am, you are able to see the video. It's not audible?
Yes, ma'am, it is audible, ma'am.
Yeah, okay.
If someday we got to the point where there were robots every place, they were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart, that's way out in the future.
So our founder, Microsoft Bill Gates, has given a statement that it should be much easier and a risk process also.
And probably we're talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which is relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite...
So the founder CEO of Tesla is telling that there will be reduction in your process. Process means your humans.
Pilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic. We have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important.
Now becomes the superhero, where his your Sundaram Pichai, where you can hear there are some more informations what he is giving now.
Something humanity has ever worked on. Now I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. Stepping back, when you think about a lot of problems in the world today, it's because we typically have a constraint on resources. AI, for the first time, I think over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes of driving and be...
So Tesla CEO is giving the information that expecting next year a self-driven car at all places.
At least 100 to 200% safer than a person by the end of next year. We're talking maybe 18 months from now.
The idea that there's going to be a general AI overlord that subjugates us or kills us all, I think is not something to worry about. I think that is overhyped. First of all, we don't know, we're nowhere close to knowing how to build a general AI, something that could set its own objectives. But second of all, I think it's unlikely that such a thing's first instincts would be to exterminate us. So I'm optimistic about that one, and certainly don't think we need to worry about it today.
Yes, how was the video information? Your CEOs of greater, where they've reached higher heights, have told the merits with slides of your demerits also. And I found this particular video to be much useful, so I thought I would share this information to you. With this, I have to tell you with only few contents or few informations. Whatever we learn, we are learning lots and lots of data. whatever we learn, this is general information. So I have given the overall view. To a drop in the ocean I have given, but the great peoples, you have seen the video, they have told you in single sentence what would be AI and what can be AI. I think you would have heard that. But whatever we learn or whatever we teach to students, as you know, humans are rather having theoretical contents being put up, reading thousands of pages in a textbook. If that particular thousands of pages is being put up in 3 or 4 images, that will be much easier. Human tendency is that rather reading informations, it's very easily understandable or graspable by the brain, the pictures. So your mind map, whatever we learn, just tell your students that whatever we learn can be converted into your concept map or your mind map. A mind map is nothing but whatever I think, that will be put up in a sheet. My hands will be flowing. There is no typical structure or typical format or any symbols, etc. Whatever you understand, everything can be given. This is a freehand diagram which has been shown of machine learning. This is not been drawn, it's taken from some other place, but it's been done. So whatever I do is, whenever I go for my students, whatever concepts I teach, if it's a module number 1 or it's a unit number 1, what I'll do is, after teaching, I'll tell them to draw a mind map or a concept map. What have you learned today's class or this 1 week of class? Give me a picture. I'm not asking them a technical question. I'm not asking them mathematics. If they know the concepts very clearly, they'll be able to do all this. So your mind map, you can use some tools for drawing this, like a smart draw or eDraw, some set of open source tools which can be taken to, for your drawing of mind maps. So areas of research in data science, working on data storage, retrieval, processing, reduction, dimensionality of your reduction of your data size, learning of spatial data. So these are the areas where research is going on and on. So till now, I think at least to some extent, I have given some set of informations of what is AI. I have given out of this 1 hour, I know that I have told you only what is AI. At least some extent, you'll be able to understand some examples. What is AI? What are the algorithms being used? Where are we now? And next 40 years, where we will be. So as educators or as teachers or researchers, the big justice what we can do is that just make use of lots and lots of data what we have, your big data, voluminous of data. Only justice what we can do is nothing but you can learn or you can work with your big data. Thank you, always thinking people, attend all these FDPs to gain more knowledge. So always I tell, not thank you, I just tell them happy thinking people. Thank you all.
Thank you, ma'am. Dear participants, if you have any questions or queries, you can unmute yourself and you can ask your questions or queries.
Hello, ma'am. Am I audible?
Yes, sir. Yes, sir.
Ma'am, as you have given a very good presentation on artificial intelligence, and you have shown us that in 2060 we will be in super intelligence era. But there are so many risks also involved with it, and there is a few segment of scientists who are saying that we should not go beyond to general intelligence, because if the computers will be super intelligence, it can overpower human beings. So what do you think, ma'am? What do you say? Really, super intelligence will benefit us?
I just gave the keywords that it will, to my, I think this sentence is according to me, benefits would be only to 40% or 50%, remaining 50% would be a risk for us. We have to be equivalent enough to compete the mission. So this is my view.
As the development of different models are coming up and quantum computing is also coming, so it is going to give enormous amount of power to the machines. because
Yes,
quantum
sir.
computing is also going to add into the computation power to the machines.
So
So if
quantum
we keep
computing,
on
there
doing,
are researches which has been going on in quantum computing now.
yeah, ma'am,
I thought
and
I
most
should
probably
I
maybe
should know this
within
particular word.
within 5 to 10 years, you will be seeing quantum computers in maybe commercially available to everybody. So the
Yes, sir.
way the research is going on in this field, so it is going to boost this, because if computation is boosted, naturally all these systems will automatically
Surely it
get
will
a
boost it,
boost.
sir. Yes.
So
We will expect all this. We should be enough
right,
face.
ma'am.
We should be trained enough to match with that, all that.
Right, ma'am. And there are so many models, ma'am. Can you tell us that how to get information about all these models? Because every day, like GN has come, then autoencoders have come. Now
Yes, sir.
transformers are coming. There are so many models are coming, and actually, all these informations are not. Can you tell us some resources from where we can get updated with
Sir,
these
whatever researches,
advancements?
what we do is like we can get these informations only based on the papers which is being published. Number one, main key source is nothing but the papers what we read. Second thing, the informations which we get day by day on your industry sites.
Right, ma'am.
So your
The
industry
reports, complete
informations
reports.
and your paper, yes, and your paper which is being published day by day, getting updations would make you update to 50%, not to 100%.
Okay, okay, ma'am.
Because they are the industry peoples are the one they are introducing all these concepts.
Yeah, ma'am. Yeah, they are actually
That is
doing
the
this.
thing. Yes, sir. Yes, sir.
Thank you.
So
Thank you
with
very much,
this,
ma'am.
thank you for this particular session. I had few questions and people started answering me also when I asked my questions. It was really interactive session. I think I have given justice to the last 1 hour.
Thank you so much, ma'am. Thank you for.
Thank you.
It was very much useful to the participants, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Thank you.
Thank you, Vani ma'am.